on this problem, let's say we're modeling something. I have seen this used for something like infectious diseases or whatever, where X is the number of years and N is, say, the number of cases of disease in millions or something like that. Let's say, how many cases would you expect in, say, 25 years? So I would put 25 in for X. The square root of 25 is 5 plus 10. I get N plus 5 plus 10 is 15. So I would expect 15 million cases of the disease, or you might be modeling something else. This is similar to a cost model, but set up a little different. I've got variables instead of that function. So in 25 years, I would expect 15 million cases. Don't forget, if it's in a unit, say millions or something like that. You want to always remember that. Now let's say, same one. Let's say I had N equals the square root of X plus 10, and I was asked to find out, all right, at what point will there be 20 million cases? Okay? So I would put 20 in for N. Now I'm looking for a time down the road. How many years from now? So I would subtract 10 from both sides, and I would get 10 equals the square root of X. Now remember, when I have a radical sign, if it's a square root, I square it. If it's a cube root, I cube both sides. This is a square root, so I'm going to square each side. Square 10 squared is 10 times 10. That is 100. Square root of X squared is a plain old X. So I expect a total of 20 million cases, say if it were a disease, 100 years from now. That's interesting. So in 100 years, I would expect 20 million cases of this disease. These are easy. You follow those rules. Make sure you're looking at your text. It has a lot of good examples. You can do a real good job with this. The key to all this is practice. Do odd-numbered problems. Check the ones in the back of the book. Check some of the ones that I do. I wish you the best.